everyone, this is Professor Thayer, and today I'm going to talk to you about the Raspberry Pi. Let me get my slides for you and share my screen. So the Raspberry Pi is a microcomputer that you can use to do all kinds of really exciting things. And I'm very excited that we've gotten a grant from Wesleyan in order to be able to develop some Raspberry Pi projects. So unfortunately, we're not able to be on campus right now. So what we've done is modified what we're able to offer you so that you can at least get started on this exciting project by doing the coding that you'll need in order to actually do your Raspberry Pi project. Let me just swap these out. And there we go. All right, so what we're going to talk about today is an introduction to the Raspberry Pi, talk a little bit about what it is and what it is useful for. We're going to also talk about microcontrollers and how they relate to the Raspberry Pi. Talk about what else you can do with the Raspberry Pi, many exciting projects you can work on. And then we'll talk about the first Pi project, the one that everybody does and that we'll be doing with a little bit of a twist. So then, introduction to Raspberry Pi. So what is a Raspberry Pi? Well, it's a single board, low-cost, high-performance computer that was developed by Adafruit in the United Kingdom. It allows you to basically work on computer programming on a very small scale, and it was developed to make it fun and interesting to be able to integrate electronics with computing. Because of its ease of being able to manipulate it, it has become a staple of the maker community and also something that a lot of people who are interested in electronics have gotten very interested in, because it really does sit at the interface between computer science, electronics, and robotics. It's very small. You'll see some pictures throughout today, but it's maybe slightly bigger than a credit card. It's somewhere between the size of a credit card and a cell phone. Very small and very light. And it's also pretty inexpensive. We'll talk about some of the different ones. We're also, when you're able to come back on campus, we have money to actually buy you Raspberry Pis that you can keep as long as you do the workshops. That's the deal. You have to do the workshops, then you get a free Raspberry Pi with the idea that you'll continue to develop it and be interested in doing exciting projects with it. But just to give you an idea, you can buy a Raspberry Pi B+ for around $35 or $40, although usually you want to buy it in a bundle package, and that goes for about $70. But you can also buy the cut down versions that have fewer components in them, and you can buy those as cheap as $5 or $10. And so it really makes it extremely affordable to buy a lot of them and to do all kinds of exciting projects with them. They're also readily customizable, and this is something that's not really so true with maybe regular laptops and computers, because it would be a little bit difficult to figure out how you're going to interface with other devices. So you may have had the experience of working with maybe some laboratory equipment where you plug it in. Typically these days it would be via USB, but you would have to write a program and it would go across that. And for beginners, maybe that's a little more complicated than where you're at this point. So what we have on the Raspberry Pi is, you'll see, is some actual pins that you can put your wires right onto. And that is how we will be interfacing with the components that we're going to make. There have also been a wide variety of products that have grown up around the Raspberry Pi. Touch screens, displays, hats, we call them hats. They're little like integrated circuits and so forth that are built out that you can plug in the Raspberry Pi. Bonnets is the same idea. Cameras for AI, plates, and there's many development packs available where you can just buy a kit that would have all the components that you need. But more exciting than that, you can also get your own collection of components and start building, which is really where the excitement begins. So this is just an overview of all the components that are actually on the Raspberry Pi board. So this here is what the Raspberry Pi board looks like. There's a variety of important things that are on this. So we're going to have our are 40 GPIO pins. This is what I was talking about. You have these pins that you can interface with, and you just use a piece of wire that has a little clip on it, and you can stick onto these various pins. And these pins have certain meanings, like some of them are power pins, and some of them are data pins, and there's also ground pins. So you might know you need ground from studying electronics. This is going to be our CPU. This happens to be a quad-core CPU. As you can see, they're a little bit slower than, say, your laptop in terms of processing speed, but there are some advantages to having it be so small, and maybe it's considerably less expensive than other things. So maybe to power, you know, blinking lights or your coffee maker, you don't need it to be blazing fast. And so those kinds of concessions to make could be totally reasonable to have a small cut down version. We also have a Bluetooth Wi-Fi on board here. So this is your Bluetooth right here. There's going to be micro SD card slot. So this is basically going to work as your hard drive. So in your computer, you would have a hard disk on your computer that has the operating system. There'll be a micro SD in your Raspberry Pi that has the Pi operating system on it. We have the DSI display port here. We have the micro USB power input. So this is where you're going to plug it into a power supply. So you have to buy, you get a cord that goes with it to plug it in, just like any other device. This is an HDMI video output. So this is where you can plug into a screen, touch screen, or you'll see some pictures of some of my Pis. I just have a regular monitor and I just plugged in with the HDMI cable. This is a port for a camera, so you can actually just plug a mini camera right in here. This is oftentimes used for artificial intelligence. There are all kinds of hats you can buy for this. There's a video and audio output jack, so you can actually plug in, say, like some headphones here, and you can listen to music on your Raspberry Pi. The LAN port, some USB ports, which I'm sure you're familiar with. And this gives our overall dimensions in millimeters. So like I said, it's basically a little bit bigger than a typical credit card. So part of the reason why these became so popular is because the Raspberry Pi and other microcomputers can be used to control devices. And so that brings up the idea of the microcontrollers, which are going to be the chips that are inside of the various appliances. And so those need to get developed somehow. And so somebody wrote the code and they didn't necessarily know how to make them on that board to begin with, how to make that microchip. So it allows you to prototype them. And in some cases, the Raspberry Pi and other similar components are so inexpensive that they may actually just be left right there as part of the microcontrollers themselves. So let's just talk about a microcontroller here. So we've got some pictures of what microcontroller chips look like. If you've ever taken a peek inside of any electronic devices, I'm sure you've seen something like this. These electronic components are in most all of your household devices. I happen to have a calculator sitting with me right here on my desk, and the second one, cell phone. I have music player, vacuum cleaner, and coffee makers, and washing machine, dryer, dishwasher. And the list goes on and on. We have these things around us all the time. It would be difficult to imagine life without them. So a microcontroller is basically a small computer that's going to typically sit on a chip, but as I was mentioning, it may actually include a Raspberry Pi itself, or maybe some of these other competing boards that are similar to the Raspberry Pi. It's going to include a CPU, which is going to be the processor cores, along with memory and the programmable input and output peripherals. Basically all the things that you would expect in a computer. So it really is a mini computer. They are needed when you need to automatically control products and devices. So what you're going to have in there is some inputs and then some outputs, right? So the inputs will come from some kinds of sensors that are associated with the device, and then the outputs will be whatever the controller is going to do, such as make your coffee or start your car or whatever it is that is the thing it needs to do. So It's oftentimes used for specific applications designed to implement certain tasks, so something that's going to be done over and over again. Automatic control is an important part of it. Some more examples here: power tools, car control systems. But there's many, many more things than just that. I'll show you a couple of examples from industry. They tend to operate at lower speeds, around the 1 megahertz to 200 megahertz range, which is, as I was mentioning, much slower than your typical computer. But is that fast enough to, operate a power drill? Absolutely. And so you have to do a trade-off. Do you want to put the inexpensive laptop processor in your drill? Will that really make a difference in how well it, changes its speed? Probably not. And so there's definitely advantages to working with some of these cheaper chips, depending on what application we need to use it for. So let's take a look at the components of microcontrollers. This is an example of a microcontroller broken out. And so you're going to see basically here, the idea is that it is very similar to what you would expect from a regular computer, just everything is miniaturized. Right, so you're going to have your processor, you're going to have your RAM, you're going to have memory, and all of this is going to have a variety of chips, right? So each of these chips may perform a very specific function. So in the world of electronics, typically what people do is they work out what the circuitry ought to be by using breadboards and wires and the various electronic components. And then you would, once you work it out and troubleshoot it, you would then design that in a more compact way, and they can be fabricated for you. As a matter of fact, there are even websites where you can just go and submit your plan, and your circuit boards will come back in the mail to you. So this is an example of using microcontrollers to control some CNC machines. So in the industry, there are many machines that need to do things such as milling things, cutting things, processing things, making things. So in manufacturing, this is very, very common. And so in this case here, what we see is this is the breadboard back here, this white thing with all the holes in it. And so basically this allows you to easily just plug things in without having to actually solder them together. So it's just temporary, right? So you can work out what it is all you need to have in your circuit, and then you can undo that. And so we have some of these components here. So for example, you see here's the screen on here. This could be an example of a hat where we're going to be putting some predefined information in here already. So this is basically a piece of a circuit already made. Sorry, I have a mosquito in the house. And so we have several of these all linked together. And so these various components then can do things such as control, the manufacture of vehicles and so forth. And so this is part of the reason why we need to have microcontrollers. This right here looks like this is not actually a Raspberry Pi, but this is a very Raspberry Pi looking board right here. So this is an example of a CNC milling machine. Like I was saying, there are an awful lot of these things that need to be programmed up. And so what we were seeing before could be an example of how somebody would actually work out which components would need to go into the final product. So you see here, there is the control panel. So inside of this are all the microcontrollers and all the programs to make this machine do the things that it does. So this one happens to be a lathe that's actually going to do some turning. So things that are cylindrical, this spins around, and then it's going to cut out and drill holes and so forth based on that. And so you would write your program in here, and then it would do that. But somebody had to actually design that program, and usually people don't start from scratch, and all the electronic components need to be worked out. And that's why you would need to do the breadboard and put all those pieces together like we were showing you before. And you see that this is a different screen, but this is a screen nevertheless mounted in this, just like you saw that we could plug a screen into that breadboard. So this is the more permanent circuitry that's been made in a more official kind of a way that you would reproduce, mass reproduce to put into all of the machines you're making. And this is just another example of a tooling machine, how it works, and many things need to be controlled, such as the the speed and changing the bits and the cleaning. You can also see that there's some water in here because these things heat up and you have to manage that as well. So there's all kinds of things that need to be managed, and that needs to be done using sensors and the program to code in what actually you're trying to make here. And that's why you need to program them up. And so that, of course, is a big driving part of the industry. And so that a lot of that was very much involved in the development of the Raspberry Pi, and to try to make it so that it would be more accessible for people to do that. So suppose you wanted to develop a microcontroller, what would the steps be? So you could use the Raspberry Pi to work out the circuitry, including the sensors, the code, and the output that would be involved, test it out, troubleshoot, figure out what you want to add, start simple, add more detail on, prototype it up. Work on the breadboard where you can easily rewire your project, so maybe something didn't quite work, or maybe you need to improve it. When your electronics are working, you can do the online services to create the miniaturized versions of the boards and or chips. So there are places that will manufacture these chips for you and help you to miniaturize your electronics. I suppose some people might do it themselves. There are actually some kits where you can do some castings and etching kinds of things to do that as well. And many of these things, you may actually just want to integrate the Raspberry Pi or your microcomputer, such as an Arduino, which is another variant of the Raspberry Pi, right into the final product. And that, in fact, actually is not so uncommon. You might not want to do that on a coffee maker because that would make it kind of expensive, but for something else, such as, you know, these $60,000 manufacturing machines, the cost of a Raspberry Pi is not really going to add that much to it. So it could be very appropriate to do, and that is regularly found in the industry. So maybe you're not particularly interested in CNC machining and in the industry, but maybe you're interested in developing, and there's lots of other things besides just how it got developed in the first place that it can be used. And I'm going to show you a few other of those things. So looking around my house, we actually have Raspberry Pis that do some interesting things. This is a Reef Pie, Raspberry Pi customized for reefs. It actually resides inside this box here. As you can see, has a bunch of outlets on it, so it turns on and off the outlets to power a variety of complicated sensors and so forth that are going to maintain our reef tank. Here's some of the reef tank stuff over here. We have, for example, our wave maker, and underneath that, this is cut off a little bit, but we have our pumps here that are going to put in the calcium, because that needs to regularly be replaced on our reef. And over here, we see an output on the sensor. So because it has Wi-Fi in it, it can send information over the network, and then you can go to the web page of the server where it's stored, and you can actually monitor things. So we have, for example, monitoring the temperature, when the heater and cooler goes on and off, the lights, and so forth, many different things that you could monitor. So all of that is automated, and our tank is well maintained because of the Reef Pie. We can also do parallel computing with a Pi cluster. So this is an example of multiple Raspberry Pis linked together. You can see this features 1, 2, 3, 4 Raspberry Pis all stacked together in this housing. And so they operate just like a real cluster would, that you have one head node and then you have several other nodes. They can all do computing, and so you can actually submit jobs and do parallel computing with a mini Pi cluster. Of course, not as fast as our HPC, high performance computing cluster, but for parallel jobs, there are things that it can do. And oftentimes Raspberry Pis can be used for doing artificial intelligence recognition, for example. This is a Raspberry Pi on my somewhat dirty dining room table here. I'm always embarrassed to show this, but it gives you an idea of what actually it looks like and what the size of it is and what it looks like when you're actually doing a project. So this is my computer screen. This happens to just be a screen we had laying around that wasn't being used. And this is a spare keyboard I picked up. And here's my Raspberry Pi sitting right here, all wired up to this screen up here and to the keyboard. Somewhere on here, there's a mouse. Oh, yeah, right here. And you can see what we're doing in this project is developing a notification system here. So this is going to flash some messages, some reminders for us. And we're working on doing up the wiring here. So that was one of my projects about a year ago. Here is an example of something similar to the Raspberry Pi. This is the Arduino, which is a cousin of the Raspberry Pi. It itself can't be programmed, so you have to program onto a disk. But this is also extremely common, and this, as you see, can also display a message on this screen, and this is an example of that in action in our kitchen. This is this is the Magpie, which is the publication, and it has a variety of different projects that come out every month. So if you're interested in learning more about Raspberry Pi, you can use the magazine. You could subscribe to this magazine and learn all kinds of interesting projects that people are working on. So this one has an article in it about Raspberry Pi, using it for retro gaming. You can also make robots. Notice that there's a variety of sensors on this, and so you can have some rules about how it's going to drive around based on the inputs that it gets. I actually had a student who undertook doing a Raspberry Pi robot for his final project in my Comp 112 Intro to Computer Programming class. It was a very interesting project. He now is off studying engineering. We also have a wide variety of other Raspberry Pi projects. So there's as many projects as there are reasons for learning how to program and to use the Pi. So again, you can check out the Magpie if you are interested in learning about more projects. So those are all interesting and great things, but they may seem a little bit daunting. I would have to say that it is quite possible to gain skills relatively quickly, just because so many of the things you can purchase as components and then put them together. So it's like a really sophisticated system of blocks, which is really exciting because you really can do quite a lot by just learning a few basic concepts and then applying those to your projects of interest. But where everybody starts is the blinking LED light. And so that's what we're going to have you do as your very first Raspberry Pi project. So the vision for the Raspberry Pi project is that it's going to go over a series of workshops that we're going to offer over the year, and hopefully we're going to be all able to be back on campus soon so we can actually get in and do this. So this is actually put on by Ideas and the CIS. And so what we want to do is we want to integrate the opportunity to actually make something. So we wanted you to make a housing for this, and then also develop your own blinking light. So here's a Raspberry Pi controlling a blinking light, and then the idea is you would take this light and you would put it inside this housing instead of, say, like a candle, and you could have it blink out something interesting. So what that interesting thing will be is what you'll work on today. So you can do the plain blinking of the light project. Unfortunately, we can't do that hands-on, because that's really where you'd typically start first. We can't do that. But what we're going to do is we're going to learn how to blink a virtual LED using Python. And then you need to code up the Python to do something more interesting than just blinking it on and off, right? Because you probably want to have your light do something more interesting than that. So we're going to challenge you to think up what you might want to do for a more interesting light blinking. So we'll start by developing the code for doing the Pi blinking light. Then we're going to learn how to use the Raspberry Pi and wire the circuit. So we do that when we get on campus, and we can actually give you the Raspberry Pi. Then we'll design and create the laser cut wooden housing for your LED light in the Ideas Lab. So this is an example. This is kind of a complex one, but you'll have some opportunity to design some kind of a housing and learn how to use the laser cutter. So Dr. Muller has graciously agreed to participate in this, and he's been really excited to learn about the Raspberry Pis and get involved with this. So that's why we're going to have this collaboration between us. Unfortunately, that's going to be pretty tough to do online, so that part of our project has been postponed until the fall or other times. Then the next thing we can do is solder your light project together. So you see on the red board, it's gonna fall apart, right? So now that you worked out how to put it together, you can actually solder the pieces together and make a more permanent structure that you can just plug onto your Raspberry Pi here when you want to do this one, and you turn it on and use it. And so then after that, the idea is the Raspberry Pi that we give you will be yours. And we hope that we'll be offering more workshops, and that you and others who are involved in learning how to use the Raspberry Pi will then start to create this group of people who's interested in developing Raspberry Pi devices on campus. So we can envision getting people through some introductory workshops where people get basic skills, and then maybe offering, you know, a rotating pool of some advanced ones where we can do some of these other more intricate projects that I was showing you. That's our vision for the future. So this is what we're going to get you for the workshop materials. You will be supplied with a Raspberry Pi. This is the power cord for it. This is a Raspberry Pi housing, so you can put it inside of this little box so it doesn't get bumped or whatever. This is another example of what that looks like, and this has a screen on it. So instead of using a huge monitor like I had, there are also these mini screens. This is maybe about the size of a cell phone screen, and this is a touch screen for your Raspberry Pi, so you'll also get one of those. You also need some of the components, so we're going to need some wires, some resistors, some LED lights, the breadboard, and so forth. So we'll also supply you with those components. And then this down here, and this is the board, so we'll give you some board to actually laser cut this in order to make your housing, whatever you decide for your design on that. So this here, again, is what the Raspberry Pi actually looks like. This is my Raspberry Pi project, and I'm just pointing out here all the various things. So when you get your Raspberry Pi, you'll need to hook it up. So we'll help you with that. Here we've got it hooked up to the keyboard. This is my Ethernet internet. It also works over the Wi-Fi. This just happens to be hardwired here. We have the HDMI. This is going out to my monitor, and this is my power supply. So this is what it will look like, and we'll of course go over this with you again in more detail as we get closer, but just to give you an idea of where we're going with all of this, right? You'll need to wire it up to your various pins, and so we're showing you here these pins here on the Raspberry Pi, which have specific meanings. And so this is what the wiring diagram would look like. If you're familiar with electronics, you know that there's also circuit diagrams, but we're also going to work with those of us who are not electronics specialists yet. Pictures might be helpful. So this is what the wiring should look like. And so this basically is the diagram for what I'm just showing you. And so in order to do this, what we'll need to be paying attention to is the pins. So this is an example of the pin diagram. So there are 40 pins on the Raspberry Pi, and they're numbered. So the way they are numbered is they go 1, 2, and then it goes back to the left, 3, 4, 5, 6, 7, 8, and so on, all the way down here, all the way up to 39 and 40, so that the evens are on the outside and the odds are on the inside, and each of these has a specific meaning. So if we look over here on the pin diagram, which is reproduced in your lab for your reference, we can see that they don't all do the same thing. So GPIO stands for general purpose input and output, and there's many of them, and so they just have different numbers so we can keep track of which one is which, because when you're trying to send out a signal, you will need to tell which pin you're powering. And so that's where this pin diagram will be useful. So we're actually going to use GPIO 25. I mean, not that there's a specific reason why you have to use this one, but it's on the outside of the board, and it's right in the middle, so it seems like a good one to pick. So the signal to turn your light on and off, turning that electricity on and off to run your circuit, will happen over the GPIO 25 pin, which is in position 22. So it's important to note that there are the pin numbers, which is just their index counting from 1 to 40. And there's also these name indices, which are not necessarily contiguous because they're interspersed with a variety of other things. So you notice that you'd need to power this. So you're going to have these power positions here. So that's 3.3 volt. And we should also have a 5 volt available, which is here on the other side. So different voltages are available. And what you do is you'll hook that to the rail on the breadboard, which basically means it's like one wire that you can electrify so that you can pull power off of that for the various things that are in your circuit. So we'll be hooking up to one of these. And also, in order to complete a circuit, you need to also have the ground to bring it around. So you see that we have a couple of ground pins available as well. So that's what the pins mean, and that gives you an idea of the kinds of things that are available on the pins. So we'll have to be addressing those pins in the code. And so this is an example of the blink LED code. So here is my breadboard wired up according to that picture that I showed you, and you can see how it works is the wires just connect between here. They just snap on either with a little cap on the end, or they have a little pin. So you put the pin side in here and the caps fit right over these pins here. And so you just get the wire, and here's the LED light, and there's a little bit hard to see, but there's a resistor in here to make sure that we're not overpowering the LED and ruining our components. So we have to set that up correctly. And so we're powering the breadboard, and then the electricity runs through and powers the LED. So the code that actually runs this to make it blink on and off is something that you have to write. And so this is a really simple one taken from this Easy Raspberry Pi projects, modified for our use. And so what we're going to need to do is import some library. So the GPIO0 library is a library that you're not going to have on your laptop. Could you download and install it? Yeah, you could, but the thing is that if you try to actually execute that code, you probably do not have pins on your laptop, so it's not really going to do anything. So that's why we're going to use the virtual LED today, and I'm showing you the code so you see where we're going and hopefully can understand why we need to program it. Okay, so you may be familiar with importing time. So we're going to use the sleep module out of the time library, and so we're going to do that because we want to be able to tell Python how long to leave the light blinking. So here is object-oriented programming. So this LED is saying, let there be an instance of an object called LED, and it's going to take the value of 25. That's its pin number. So that means we're going to use GPIO 25. That's what this is specifying here. So if you want to find out more about that object, you can go to the GPIO0 library, open it up, and read it. So somebody else wrote some functions and so forth, and some objects that are in that library, and we're using those objects in our code. That's what's happening here. So the next thing we're going to do is create a variable called delay. So I've set this to 30. And so, yeah, this is obviously not a 1 second delay. This is going to be a 30-second delay now, but you can, of course, change this number. The point is, though, that it's going to be the number of seconds. And here we have a while true loop, and so this is going to continue infinitely. So this is on purpose an infinite loop where you're going to just keep running, and what's going to happen is it's going to turn the LED on and off. So here is our instance, right? So our instance of our LED light. So we're going to do LED.on. So that means that LEDs have, so LED, by the way, stands for light emitting diode, which is this light bulb thing here. This LED, this object, has a method called on, which is going to then handle making the electricity run through to the pin 25 into your wire. So that's what's happening. And so when we do LED.on, that's what it's doing, it's turning it on. And then we're also, for our help, we're printing set LED to on to the screen so that we know that that's supposed to happen, just in case your board doesn't work. It's a good way to troubleshoot. And the reason why we need to put a delay in here is because Python can execute so fast that it would just blink it on and off and on and off, and you wouldn't really be able to see what's happening. So what we do is then we stop Python and say, okay, slow down, sleep delay. So then it will stop processing the code for the delay period of time. And then we're going to turn the LED off. And that is going to be off for 2 times delay. So you can, of course, change how long it's blinked on and off, and that will be part of what you're going to do in today's lab, is play around with that and also play around with this loop. Of course, we could take this and we could put this inside of a function, which would probably be better programming, which is another thing that we'll bring up with you in today's lab as you're working through some of our code. Okay, and so actually this is just another view of our code. It's basically the same thing. And so that brings us to today's lab. So what we're going to do is we're going to use turtles to create a virtual LED light, which is, I know, not as exciting as using the real LED light, but it will allow you to basically work up your code to blink this little light in the turtles. And you can then work out some interesting patterns and get your Python code done so that when it does come time to actually do the real one, you'll have already thought up something interesting to do and have the code already laid out. So we'll be providing you with a variety of starter code to write the blinking light algorithms. We have the basics for your turtle already set up. So you'll blink out the SOS pattern on your LED, and also think about doing some Morse code messages. You could also think about doing something interesting. So you'll do a couple of set examples, and then we'll challenge you to think up what it is you might want to do for your actual light that you're going to put in your housings. So maybe you want to blink several lights to make some patterns, turn them on and off. You can also keep in mind that the LED lights do come in a couple of different colors. We haven't actually purchased your kits yet, so I don't know what colors we'll get, but the typical colors that they come in are red, green, yellow, white, and blue. So you could think up of maybe making some designs with multiple lights and having them blink on and off. So there's just a lot of different things. Another thing I suggested is you could take it and have some kind of an input that would blink out your favorite song. So if you've ever seen some of those light up speakers, they'll detect the notes, and when the notes stop, and they will blink on and off according to that. So you might make up a system of how your favorite song goes and doing that. So you might think about doing that, or maybe you have another idea, and certainly you're welcome to develop whatever light blinking idea suits your fancy. All right, and then because we've shown you the actual code for doing the actual light on the Raspberry Pi, something you can also work on now is you could convert that code to use with the Raspberry Pi. So although you won't be able to test it on the Pi itself, you can test it out in your regular, in just this virtual LED. And then what you can do is you can write up the code for the other version, which will actually make use of the GPIO0 library, so that you'll be ready to go when the workshops become available this fall. All right, so I hope you've enjoyed learning about the Raspberry Pi, and I hope you're as excited about getting started with this as I was when I first started using the Raspberry Pi. It's a lot of fun, it's very hands-on, and it's a really great way to get even more into programming and also to interface between programming and electronics. And we're definitely really excited to have the opportunity to be able to bring this into the makerspace so we can actually do things like solder the project together. And even more exciting is to actually be able to construct your own housing, which you'll hear more about when we get to that point. All right, well, thank you very much. I'd like to encourage you to go pick up the exercises I've prepared for you to work on today, and certainly reach out if you have any questions. All right, enjoy.